Sorry guys, I apologize for that interruption. Like I was saying, what we're doing is we're looking for the center of dilation. And remember, we said in the last section, you can find that center of dilation by drawing line segments that connect corresponding vertices. So K and O are corresponding vertices. I'll do this in blue. And there's a line that connects those guys. Then G and L are corresponding vertices. Draw a line that connects those guys. Awesome. J and N corresponding vertices. Draw a line that connects those guys. And H and M corresponding vertices. Draw a line. And what we said is that the point of concurrency is the center of dilation. So it turns out that you can not only let me know the scale factor is 2 and write a similarity transformation, you can also tell me that the center of dilation is 0, 0. Is the origin, right? Those lines all come together at the origin, the center of dilation. All right, I got another one for you here. Let's try this one. Oh, actually, I apologize. There is a typo here in this problem. I forgot to give you the ordered pairs. So real quick here, let me give you some ordered pairs. A is going to be at 1, 6. B is going to be at 5, 6. C is going to be at -2, 2. And D is going to be at 2, 2. Okay, so now that we've got the actual ordered pairs, again, I apologize, I left those out. What we're going to do is we're going to look at a sequence of similarity transformations. Now remember, a similarity transformation could be a dilation, a reflection, a rotation, or a translation. So these will not just be dilations. We're going to throw in some of that other stuff again from way back in chapter 1, so remind you how to do it. You'll pick it up again real quick. Just a refresher here on how those go. So what we're going to do is we want you to map the pre-image to the image using the sequence of transformations that I've given you right here. In order to start, first we need to map our pre-image. Excuse me. So in A, we'll do all of them in red. Sure. 1, 6. Right there. Then 5, 6. Then -2, 2. And then 2, 2. All right, so right there. There's my pre-image based on those pairs. Now, how do I find my image? Well, remember, we're going to apply the transformations to each of the points. So here we go. We start with A, which is at 1, 6. I applied the first transformation to get A prime. All right, well, what I'm going to do is I'm going to multiply the x by 1/2 and multiply the y by 1/2. No problem. 1 times 1/2 is 1/2. 6 times 1/2 is 3. Okay, but that's not it. I then have to do this transformation. Hopefully you recognize it as a translation. So what I'm going to do, right, is it says to take x and add 2. Well, my x is 1/2. So add 2. That's 2.5. This says subtract 3. Well, 3 minus 3, 0. And so what I've got is I have my original point, 1, 6. There it is right there, 1, 6. The new point is going to be at +2.5, 0. Right, and that's after doing these transformations. Let's do it for B. B is at 5, 6. All right, well, the first transformation says divide both the x and the y by 2. So B prime, 5 divided by 2 is 5/2, which is 2.5. 6 divided by 2, again, is 3. All right. to find b double prime. Right, it says to take 2.5, add 2. 2.5, 3.5, how about 4.5? And then, again, I'm going to take the y value, subtract 3. Well, 3 minus 3 is still 0. Great, next one, c. C was at minus 2, 2. Here we go, c prime. Actually, this one's really easy, right? I'm multiplying both of those by 1/2, but that's exactly the same thing as divide both of them by 2, right? Divide both of them by 2. Well, anything divided by itself is 1, so this is going to be a negative 1, and that's going to be a positive 1. Minus 1, 1. Now, do the translation. I'm going to add 2 to this one. I'm going to subtract 3 from this one. If I add 2, negative 1 plus 2 will be a positive 1. And if I take 1 and subtract 3, that's going to be a minus 2. And then my last one, d. Well, d is at 2, 2, so d prime is going to be at 1, 1. Right, I'm going to divide each of these by 2. Well, 2 divided by 2 is 1. And then I got to do my translation. Excuse me. Okay, so I have 1 plus 2, which will be 3. And then I have 1 minus 3, which will be a minus 2. Now all I got to do is plot these guys. I will do them in green, so let me plot these guys in green. Here we go. 2.5, 0, 2.5, 0, right there. I got 4.5, 0. There it is. I got 1, negative 2. And I got 3, negative 2. And right there is my image. So, in red, the pre-image, what you started with, ordered pairs I forgot to give you, sorry about that. But then we go ahead and we do our similarity transformations, and sure enough, I have an object that is the same shape. All the angle measures are the same. It has just been shrunk, right? We did a dilation where the scale factor was 1/2. So K is equal to 1/2. This is a dilation. And again, hopefully from chapter 1 you remember that that next one was a translation. Where all we're doing is we're taking our figure and we're moving it in the x-axis over 2 and then the y-axis down 3, right? This is going to shift it over 2 and then the y minus 3 will move it down 3. So we're taking our object, shifting it over 2, moving it down 3. This one was gonna, that's why it got shrunk, right? The dilation. The scale factor was 1/2, which shrinks my image. Right? Head on over to the next page of the notes. I have another one of these for you. We'll try yet another similarity transformation. I'll meet you guys there.